So in question 10C, we have here going from blue to red. And it's really difficult to see, but from blue to red, we actually have a vertical flip and a vertical expansion and also a horizontal flip. Okay, so if I kind of take a look at this coordinate here, that point there, that actually ended up getting vertically flipped up to here. Okay, so notice that the orientation is blue is down, for red it's up. So it did get vertically flipped. Okay, I also can see that the original height was 10, the new height is 5, so it's a vertical compression. Okay, so I'm going to write that in before I forget here. So I get a vertical flip and a vertical compression by 1/2. Now those are interchangeable because algebraically I'm going to times by negative 1/2 anyways. Okay, now that said, I got to keep track of my coordinates here to figure out my shift. Okay, so I'm going to take a reference point of y equals negative 6, and it's going to end up at y equals positive 10. So my starting point, so my starting y is going to be negative 6. Let me just double check that. Negative 6. And then the transformation on this was times by negative 1/2. Okay, onto the negative 6. And then the last step, which we don't know, that's what we got to figure out. That's got to get us to the end y, the ending position, and that ending position was y equals positive 10. So I'm going to end up at positive 3, and then to get to positive 10, I need a plus 7 transformation. Okay, so that shift last of vertical shift plus 7 is going to get my y coordinates to the right position. Okay, now, and I could have chosen any y coordinate. I would have gotten the exact same end position or the exact same shift. In fact, I'm going to just show you that. For example, let's say I chose my starting point was y equals positive 4. The ending position of that would be y equals positive 5. Okay, so the end is positive 5. So if I do the same transformation, negative 1/2 times negative 4, that's going to give me, positive 4, that's going to give me negative 2. Negative 2 plus 7 gives me to positive 5. So it gets me to the right position. Okay, so that's going to be the correct transformation. So I'm going to write that in, y equals f bracket. So I'm going to times by 1/2, negative 1/2, and then plus 7 to get it into the right spot. So then I just have to work on the horizontal. Okay, looking at the horizontal, what's happening? Well, there's a horizontal flip going on here. Now, again, this is hard to see because there's lots going on, but there's definitely a horizontal flip going on. And there's a compression. So it starts at 12 and it ends up 6 wide. So it starts 12 wide, ends up 6 wide. So it's definitely a horizontal compression by 1/2. And then we have to do a horizontal shift. So before I do that, a horizontal shift, I'm going to make sure I can keep track of my coordinates and figure out where I'm going to end up with. So I'm going to choose some random point, not a random point, but a nice x coordinate. So let's choose, I'm just going to choose a green point, x equals 4. Okay, I'm going to apply my transformation times by negative 1/2 on positive 4. And then my ending position for that coordinate, I forgot to check out the ending position. So the ending position, that position here ends up here. So it ends up at x equals negative 6. So it starts off at x equals positive 4, and it ends at x equals negative 6. So what ends up happening is when I do the horizontal compression, it's going to be at negative, compression and flip is going to end up at negative 2. But I've got to get it to negative 6. So I'm going to do minus 4 to get it there. Okay, so then just double checking that. Yeah, minus 6. I've got to do -4, so my horizontal shift is left 4. So there's my transformation. The problem is I need to get it into function notation. So what I've actually done and what I put into my function notation are opposite. Okay, so this is my transformation. It's going to be flip and compress first, and then shift left last. Okay, and then I need to just undo this to be able to put it into function notation. So I'm going to +4 and times by -2, and this is a notational form of this. Okay, so once I get that part, this part here is a part I put into the right brackets. So I end up with -2 bracket x plus 4 bracket. Okay, this happens to be factored form, so notice that the compression expansion happened first and shift last. Factored form is always shift last by its nature of how we organize the algebra for that.